In this video, I'll cover the deep learning story in ArcGIS and then dive into a demonstration showcasing an end-to-end deep learning workflow in ArcGIS Pro. ArcGIS integrates well with third-party frameworks such as TensorFlow and CNTK. Additionally, ArcGIS natively supports model training and inferencing across the platform through ArcGIS Learn. Our AI models support tasks such as object detection, image classification, object classification, and instance segmentation. Additionally, these models support a variety of data types: point cloud, bathymetric data, LiDAR, video, and even oriented imagery, to name a few. Now I'll switch to a demo in ArcGIS Pro, and I'll go through the complete end-to-end workflow using geoprocessing tools. First, to provide you with some context to the scenario, this is nape imagery that I've used over the region of Redlands, and what I really want to do is capture swimming pools within this region in an automated manner. So it's a multi-step process: capture training samples, export training data, train your deep learning model, and eventually run inferencing, which in this case would be object detection. So let's go through each one of the steps bit by bit. Step one is capturing training samples. So using the imagery tab on the classification tools, you have multiple options on how you can capture your training samples. You can use the training samples manager, which we've had for a very long time for classification purposes, or now we've added the label objects for deep learning tool. This tool essentially is designed specifically for deep learning workflows. So I can go about capturing pools right here. Likewise, pick another location, and here's another location, and we can keep going. Now, once you're done with capturing training samples, you can access the export training data tool directly from within this user experience. Provide your output folder, you provide your mass polygon if you have a specific area of interest, and then use the default parameters as required. Once you run, it creates a bunch of image chips which can be used for training your model. Optionally, you can head over to the geoprocessing pane. Here, as part of the image analyst toolbox, you have the deep learning toolset, which gives you access to a wide variety of tools. Step one being export training data for deep learning. You provide your input raster, output folder. Here you provide your training samples. Now, in the interest of time, I have pre-created or pre-captured my training samples. And in this case, instead of polygons, what I captured was a bunch of points. So in this case, we need to specify a buffer, 50-meter buffer radius. This is our region of interest. So I don't want to process the entire imagery. Once you run the geoprocessing tool, the output is a bunch of image chips with the metadata, and this is what it looks like. This now goes as an input to train your deep learning model. So we call the train deep learning model tool, provide the training data as an input. You specify what's your output model, the max number of epochs you want to train, and the rest are parameters which you don't necessarily need to change. We use intelligent defaults, but for advanced users, you have the ability to change these parameters. Once you run this, the output is a trained deep learning model. And the last step is detecting objects or running your inferencing tool. You provide your input raster, which is your nape imagery. You provide your output detected objects feature class. Your model definition here, you're essentially pointing to the trained model. The non-maximum suppression parameter is used to resolve overlapping features. Once you run the process, here's what the detected pools look like. We've got pools detected all of this region, and this was automatically done using deep learning. Now, the next step, what you can do is you can do quality assurance or quality assessment of these points. We've added a new tool within Pro, which will simplify the review process for you. So here's my feature class. It gives me the confidence, and it also gives me the class name. So I can click on any given feature and quickly review my results. We could even automate the process. So it iterates through each one of the features automatically until I find something that I need to change. Had this been something other than a pool, I can quickly change this to null. Optionally, if I do see a feature that is a pool and has not been detected by the system, I can quickly pick. And that's pretty much my demonstration. That's going all the way from capturing training samples to train your deep learning model to detecting objects and eventually doing a quality check on the results.